In the previous block of Video 10 Part 1, we established the hardware architecture of the especially 36 triaxial accelerometer and its method for capturing mechanical forces in 3 dimensions. However, accumulating raw data is entirely futile if the Hypercar is incapable of interpreting it. In this video, you will learn how the dynamic control Trinity operates. You will witness the velocity at which mass transfer is processed within a central network, the execution of active aerodynamics in an asymmetric manner, and the exact method utilized to neutralize inertia on the vertical axis. Welcome to video number 10 part 2. With the especially 37 infographic displayed on screen, we can comprehend the precise mathematical nexus. Today, we cross the boundary of pure data collection to delve into the physical execution of those parameters through 3 new specifications from our technical ledger. Block 1. The mathematical nexus and the ESP37 matrix. The first critical component within this deployment is the ESP37, the central dynamic load distribution matrix. This secondary processing algorithm, deeply integrated into the control unit, instantaneously receives the tridimensional telemetry from the accelerometer. Its function is not reactive, but predictive. It vectorially calculates mass transfer before the chassis physically initiates body roll. The ESP37 anticipates the Hypercar's inertia during phases of brutal acceleration or high deceleration braking, mathematically redistributing forces across the 4 wheels to maintain the optimum equilibrium of the vehicle assembly. Block 2. Asymmetric Aerodynamic Execution, ESP38. Once the central matrix has processed these force vectors, the information is immediately translated into mechanical action via the ESP38, the active aerodynamic actuation system. Forget conventional, symmetrically actuated spoilers. On the Pagani Utopia, the ESP38 governs the servo motors and hydraulic actuators of the rear flaps completely independently. If the system detects an extreme centripetal force during a high-speed turn, it asymmetrically increases the angle of incidence of the inner flap. This generates a direct aerodynamic torque that counteracts the body's natural roll, pinning the tire to the asphalt and optimizing the contact patch. Block 3. Vertical axis neutralisation, ESP39. The final pillar of this dynamic trinity operates within the vertical plane via the ESP39, the active suspension ride and inertia control module. This hardware processes structural vibration and high compression readings captured on the third axis of the accelerometer. When traveling at extreme velocities, asphalt imperfections generate parasitic frequencies that can destabilize overall aerodynamic downforce. The ESP39 instantaneously modifies the damping rate via ultra-fast responding solenoid valves, neutralizing pitch and absorbing vertical impacts. With the interaction of specifications ESP37, ESP38, and ESP39 fully dissected, we have decoded the core that allows this Hypercar to tame the laws of applied physics. In the upcoming block, we shall cross the definitive boundary into high-speed network protocols and CAN bus routing governing this massive, millisecond-range data transfer. I shall see you in the next video. Join our channel, subscribe, and share so you do not miss the final videos of this 12-part technical dissection series of the Pagani Utopia, alongside the surprise we have in store for you to pioneer a new era in hypercar analysis. Where are you watching from? Please leave your country and city in the comments section below. See you in the next installment.